Earth after human. Impacts on the atmosphere and the road to recovery. The absence of human activities on Earth leads to significant changes in the atmosphere. After humans, the planet enters a new era where natural processes govern atmospheric composition and dynamics. This article explores the impacts on the atmosphere after humans and the subsequent road to recovery. From reduced greenhouse gas emissions to the restoration of ozone layers, understanding these changes is crucial for comprehending the Earth's future and the potential for environmental recovery. The decline in greenhouse gas emissions. Impacts on the atmosphere and climate system. The decline in greenhouse gas, GHG emissions is a crucial step in mitigating climate change and its impacts on the Earth's atmosphere and climate system. Human activities, particularly the burning of fossil fuels and deforestation, have contributed to the rise in GHG concentrations, leading to global warming and associated environmental changes. This section explores the impacts of the decline in GHG emissions on the atmosphere, focusing on the stabilization of climate patterns, air quality improvement, and the potential for mitigating climate change. Stabilization of climate patterns. The decline in GHG emissions has a direct impact on climate patterns by reducing the radiative forcing that drives global warming. Radiative forcing refers to the imbalance between incoming solar radiation and outgoing heat radiation trapped in the atmosphere by GHGs. As GHG concentrations decrease, the radiative forcing is diminished, leading to the stabilization of climate patterns. The decline in GHG emissions helps prevent further temperature increases, reducing the frequency and intensity of extreme weather events such as heat waves, droughts, and hurricanes. This stabilization allows ecosystems, human communities, and infrastructure to adapt to a more predictable and less volatile climate. Reduction in global temperature. The decline in GHG emissions contributes to a reduction in global temperature, mitigating the long-term impacts of climate change. As GHGs trap less heat in the atmosphere, the Earth's energy balance is restored, leading to a gradual cooling effect. This cooling effect is particularly significant in limiting the rise in global average temperature, aiming to achieve the goals set in international agreements like the Paris Agreement. A reduced global temperature has cascading effects on various aspects of the climate system. It helps preserve polar ice caps, slows down sea level rise, preserves permafrost regions, and reduces the risk of irreversible climate tipping points. Air quality improvement. GHG emissions are often accompanied by the release of other pollutants, such as particulate matter, nitrogen oxides, NOx, sulfur dioxide, SO2, and volatile organic compounds, VOCs. These pollutants have detrimental effects on air quality, human health, and ecosystems. The decline in GHG emissions leads to a corresponding reduction in these co-emitted pollutants, resulting in improved air quality. Improved air quality has several benefits, including better respiratory health for humans, reduced risk of cardiovascular diseases, and improved visibility. It also contributes to the preservation of ecosystems and biodiversity, as many species are sensitive to pollutants in the air. Ocean acidification mitigation. GHG emissions, particularly carbon dioxide, CO2 emissions, not only contribute to global warming, but also drive ocean acidification. Increased CO2 concentrations in the atmosphere lead to its absorption by the oceans, resulting in a decrease in seawater pH. This change in pH affects marine ecosystems, particularly those with calcifying organisms like corals, shellfish, and plankton. The decline in GHG emissions helps mitigate ocean acidification by reducing the amount of CO2 absorbed by the oceans. This allows marine ecosystems to maintain a more stable pH level, preserving the health and biodiversity of coral reefs, shellfish populations, and other vulnerable marine organisms. Conservation of carbon sinks. Natural carbon sinks, such as forests, wetlands, and oceans, play a crucial role in absorbing CO2 from the atmosphere and storing it in biomass or sediments. However, the ongoing decline in natural habitats, particularly deforestation and land use changes, has diminished the capacity of these ecosystems to act as carbon sinks. By reducing GHG emissions, we can preserve and enhance the efficiency of natural carbon sinks. Protecting forests, restoring degraded lands, and promoting sustainable land use practices allow these ecosystems to continue absorbing CO2, helping to mitigate climate change and maintaining the balance of the carbon cycle. Positive feedback loop mitigation. One of the key impacts of declining GHG emissions is the mitigation of positive feedback loops that amplify climate change. Positive feedback loops occur when a change in the climate system leads to additional changes that further enhance the initial change. For example, as temperatures increase, permafrost regions thaw, releasing significant amounts of methane, a potent GHG. By reducing GHG emissions, we can limit the initial temperature increase, thereby reducing the likelihood of triggering positive feedback loops and subsequent accelerated warming. Changes in air quality, impacts and pathways for improvement. Air quality is a critical environmental parameter that directly affects human health, ecosystems, and the overall well-being of the planet. Human activities, particularly industrial processes, transportation, and energy generation, have had a significant impact on air quality, leading to the release of pollutants into the atmosphere. This article explores the changes in air quality, both positive and negative, and examines the pathways for improvement to ensure cleaner and healthier air for future generations. Negative impacts on air quality. Particulate matter pollution. One of the major concerns for air quality is the presence of particulate matter pollution. PM refers to tiny particles suspended in the air, which can be released from combustion processes, industrial emissions, and natural sources. These particles can be categorized into different sizes, with PM10 and PM2.5 being a particular concern due to their ability to penetrate deep into the respiratory system. Exposure to PM pollution has been linked to respiratory diseases, cardiovascular issues, and even premature death. Nitrogen oxides and sulfur dioxide. Emissions from combustion processes, such as those from vehicles and power plants, contribute to the release of nitrogen oxides and sulfur dioxide. These pollutants can have detrimental effects on air quality and human health. NOx is a precursor to ground-level ozone formation, which can lead to respiratory problems, while so too is associated with acid rain, which damages ecosystems and affects water bodies. Volatile organic compounds are released from various sources, including vehicle emissions, industrial processes, and household products. These compounds can contribute to the formation of ground-level ozone and the production of fine particulate matter. Prolonged exposure to high levels of VOCs can have adverse effects on human health, including respiratory issues and the development of certain cancers. Greenhouse gas emissions. While greenhouse gases like carbon dioxide are primarily associated with climate change, they also have indirect impacts on air quality. The burning of fossil fuels and industrial processes release significant amounts of CO2 and other GHGs into the atmosphere. These emissions contribute to global warming, which can indirectly affect air quality through changes in meteorological conditions and the intensification of weather events. Positive changes in air quality. Emissions reduction measures. Efforts to mitigate air pollution and improve air quality have led to positive changes in many regions. Implementation of emission control technologies, such as catalytic converters in vehicles and air pollution control devices in industrial facilities, has significantly reduced the release of pollutants into the atmosphere. Stricter regulations and the use of cleaner fuels have also contributed to emissions reductions. Transition to renewable energy sources. The shift towards renewable energy sources, such as solar, wind, and hydropower, has positive implications for air quality. Unlike fossil fuels, these sources do not release pollutants during energy generation. The adoption of renewable energy technologies not only reduces air pollution, but also helps mitigate climate change, leading to co-benefits for both air quality and the environment. Improved industrial practices. Industrial processes have undergone significant improvements in recent years to reduce their environmental footprint. The adoption of cleaner production techniques, energy-efficient technologies, and the implementation of stringent emission standards have contributed to improved air quality in industrial areas. Sustainable practices, such as waste reduction and recycling, also minimize pollution associated with industrial activities. Changes in transportation. The transportation sector has made strides in improving air quality through the introduction of cleaner vehicles and alternative fuels. The widespread use of hybrid and electric vehicles, as well as the development of public transportation systems, has reduced emissions of pollutants from vehicles. The promotion of active transportation options like walking and cycling also contributes to cleaner air in urban areas. Pathways for air quality improvement. Strengthening environmental regulations. Continued efforts to strengthen and enforce environmental regulations are crucial for improving air quality. Governments and regulatory bodies need to set stringent emission standards, regularly monitor compliance, and impose penalties for non-compliance. By holding industries and individuals accountable for their pollution, significant progress can be made in reducing air pollutants. Promotion of clean technologies. Investing in research and development of clean technologies is essential for further improving air quality. Governments, private sectors, and research institutions should focus on developing innovative solutions for emission reduction, such as advanced pollution control technologies, cleaner fuels, and sustainable industrial practices. Encouraging the widespread adoption of these clean technologies will facilitate long-term air quality improvement. Public awareness and education. Raising public awareness about the impacts of air pollution on health and the environment is crucial for fostering behavioral change. Education campaigns can inform individuals about the sources of air pollution, the importance of sustainable practices, and the benefits of clean air. Encouraging individuals to make environmentally conscious choices, such as reducing vehicle usage, conserving energy, and using eco-friendly products, can contribute to overall air quality improvement. Collaboration and international cooperation. Air pollution is a global issue that requires collaboration and cooperation at national and international levels. Sharing best practices, exchanging knowledge, and collaborating on research and development can accelerate progress in improving air quality. International agreements, such as the Paris Agreement, provide a framework for countries to work together to mitigate climate change and reduce air pollution. Air quality is a critical environmental concern with significant impacts on human health, ecosystems, and the planet as a whole. While human activities have contributed to air pollution, efforts to reduce emissions and improve air quality have yielded positive changes. Through the implementation of emission reduction measures, transition to renewable energy sources, improved industrial practices, and changes in transportation, air quality can be significantly improved. Strengthening environmental regulations, promoting clean technologies, raising public awareness, and fostering international cooperation are essential pathways for further air quality improvement. By taking proactive measures to address air pollution, we can ensure cleaner and healthier air for current and future generations. That's all in this video. If you like the information, please hit like and subscribe to this channel, and be connected to this channel for more space information.